So how's your magic show going, Wayne? I've
Oh,
heard really good things.
Yeah, really good, thanks.
Yeah?
Really good. In fact, before we do acceleration,
Right.
I've got a trick to show you.
Oh, I
It's
like
ready.
tricks.
It's top
Okay.
of the card.
Oh, okay.
So, see this pack of cards?
I agree, those are cards.
Now what I'm going to do is I'm going to shuffle this. You're not
Yeah.
allowed to look.
Oh, okay.
Okay, don't look. No looking. Right. Just.
Alright, okay, that's fine.
And what I want you to do is pick a card completely at random. From the
Completely at
deck.
random.
Completely at random.
Okay, I'm feeling. Yep, that one there.
The one on the far left, on the bottom, conveniently placed.
Yeah, that one just felt me, you know.
Okay, memorise the card. Don't let me see it.
Alright. Yep.
Yep, you got it?
Yep.
Right.
Okay.
Is this your card?
I don't think you really know how this meant to work, Wayne. Essentially, you take a card back and you don't
Take it.
Yeah.
But is this your card?
It's really sick.
Is it?
Oh, wait, hang on. That's real magic, that is. That is.
real magic.
That is. That's good.
Yeah.
Yeah.
So now acceleration, I think.
I think that's a good plan. So acceleration is a vector quantity because it's formed from vectors.
So just a reminder, because you didn't watch the previous two videos.
Yeah.
Acceleration, because it's a vector, it has a direction. Let's say it's going like this.
Yep, and that means it has a vertical and horizontal component.
Does
Horizontal being I,
Yep.
and
So I,
vertical being
and
J.
J.
Often expressed like this.
Absolutely. So if we had, it might have been told in the question,
Mhm.
something had an acceleration of, say, 3I
Yeah.
plus 4J.
Then it asks you what the magnitude of acceleration is.
Yeah, this is 3, this is 4, this is always a right angle.
Absolutely, so this becomes 5.
Lovely.
Absolutely.
Another way of expressing this, which we haven't mentioned in previous videos, is in square brackets.
Yeah, and this is how you've often done vectors with graph transformations and stuff. That still works for here.
Yep, 3 on the top, 4 on the bottom.
Either works.
So it's like x, it's like your x going in the x direction, that's how you can think of it. So
Yeah.
with vectors for transformations, your x is on the top. That's how I remember.
Yeah, that's what I do.
And that's good, but then they ask horrible questions. And in acceleration, there's no particular to acceleration questions, they just
No.
combine it with other stuff.
Yeah, so if you remember Suvat,
Hopefully
Good.
you do.
yeah, they also use Suvat with I and J, which is basically what these questions are in the exam, so they're a bit tricky.
Absolutely. So we have two lovely worked examples, I
Do we
believe.
have two lovely worked examples, hopefully? Yes, we do. Just not on that page. On this page. No.
On that page.
This page?
Lovely.
Aha. Right. So, it's example 9 on page 48 of this book, if you've got it. If you haven't, then mine will read it out anyway. So it says, there's a ship, Wayne.
There's a ship.
Very
so I'm going to draw a
exciting.
ship.
Alright, moving of a constant acceleration is travelling due east at a speed of 10 metres a second.
Due east.
Yep.
10 metres per second.
After 20 seconds, it is travelling due south at 5 metres a
South.
second.
At 5 metres per second.
Yeah.
Right.
Find the displacement from its initial position after 20 seconds.
Now this seems like an odd question, but I think it's going to boil down to a Suvat.
Yeah.
So a good step always with Suvat is to write out what you know, what you don't know, and what you need to know.
Yep. So we need to know RS, that's what we want to have in the end.
Absolutely. We know a
Start.
time outright is 20 seconds.
Yeah. So 20 seconds. And we also know our
Initial and final
Those are
velocity.
the words I was looking for.
However,
So
we
you could
could
write it like this.
say that's 10 metres per second, and this is final velocity there.
Sorry.
It's 5 metres per second. We do not know an acceleration, and we do not need to know because we know 3 other things.
Yeah. But you could also write that a bit differently, couldn't you, Wayne?
You could, because this is 10 metres per second going this way,
Mhm.
and this is 5 metres per second going this way, it doesn't make sense to bung them into the same equation as two different things, because you use Suvat for linear things.
Yeah. But these are not linear.
Not
But then
yet.
you can think about I and J because they're two dimensions.
Yeah, so if we put it in terms of I and J, then we can then suddenly combine them into the Suvat equations. This is 10I because it's going perfectly east, it says east in the question, and this is minus 5J because it's going down, it's south.
Yeah.
And now that it's in terms of I and J like this,
Yeah.
we can apply Suvat.
Where are you eating, boys? On your knees in here or in the kitchen or what?
Either works.
Whichever you want to do.
I'll need in here, be fine.
Yeah, that's fine. It'll be only about 1 minute.
So, you can do it like that.
You good? So we need an equation for S that has V, U and T.
Yep, I've got one, Wayne. I have one.
Good.
S equals a half U plus V, lots of T, Wayne.
That was Jill, by the way.
Oh, actually,
She was dinner.
she owns the house, yeah.
Should let her in, really.
Yeah.
So we have everything but S, and it's already in terms of S. So
Yep.
a half of U plus V is 15. A
Yep.
half of that is. I'm going to do that in a minute.
Yeah, so 0.5.
Oh, actually, no, because it's in terms of I and J. Apologies,
Yeah.
I was being stupid.
So then we have 10I.
10I plus
Minus
5, minus 5J. I'm just not with it since Jill
That's
came in.
fine. times 20, so then we have 10 lots of that.
Absolutely.
So it ends up being S is equal to 100
Yeah.
I.
So it's
minus
timesing both things
50
by 0.5 times 20.
Yeah.
Absolutely, and that's the
answer.
distance.
Yeah, and that does. It's not really what you're expecting. You look at the question, is it?
It's not. You've
That's a
got
very
to
good example.
think Suvat is in straight lines. At the moment, this isn't in straight lines, but if you put it in terms of I and J, then suddenly you can apply Suvat equations.
Yeah, which is really cool. And then we've got another one which uses our square brackets.
It does indeed. It's example 10. So let's hurry up, because Jill
Yeah.
said 1 minute before we
And
stuff our
she's
faces.
quite good with military timings.
Yeah.
So here we go. Example number 10, when an object is moving with constant acceleration, initially it is moving with velocity 8.1 meters a second.
8-1 like this, yeah?
Yep.
Yeah.
And after 10 seconds it's moving with velocity minus 2.4. Yes. Find its acceleration.
Acceleration. So it's another Suvat question, SUVAT. What do we know, what don't we know, and what do we need to know? That's
So-
a good catchphrase.
That is a good catchphrase to have. We don't have S, we don't need S. We do have U,
It was initially 8-1,
Yep.
or 8I plus 1J.
absolutely, and then it changed to minus 2.4, and again, that could be minus 2I plus 4J.
Absolutely. Acceleration is what we want.
Yep, and we have a time which is 10 seconds. Now you need to choose a thing.
V equals U plus AT.
That sounds like a good
lovely to
choice.
me.
So you want A, so you can rearrange that.
Absolutely. So V minus U over T is going to equal our A. We have our V, we have our U, and we have our T. I think we can just keep it as it is.
I think we can, so we
In
need to put
terms
those
of
in.
these R's and J.
So should I'll put them in.
So V is this one, it's minus 2, 4.
Yeah.
Be careful to get your V and your U the right way around. Minus your U, 8, 1. Over T, which is 10.
Right.
Now this is just like your I and J thing, so
Yeah.
when you can literally minus one from the other. So we minus the two top numbers.
Mhm.
Minus 2 minus 8 is minus 10.
It is, and then
4 minus 1 is 3. We can do that. Over 10.
you do the similar thing you would normally. So
Yeah, so each thing divided by 10 individually is minus 1 and 0.3.
and that is our acceleration. So you're going to be units, which you should do.
Meters per second squared. And that's that. Final mention, it's up in the corner so I'll mention it. Acceleration equals change in velocity over time.
Yeah.
We knew that from our velocity time graphs at the beginning of the course.
Yeah. And these are the sort of things that come up. Occasionally they are harder, but it's just applying these things. If you find a question you are struggling with,
Send us a message, either put it in the link in the comments below.
yeah.
Message us on Facebook, the link to our Facebook is below.
Yep, we're going to upload another video detailing how to do that in more detail than we're doing here.
But for now, I think Jill's going to come in with some food for us to stuff our faces.
So we'll do that.
We'll do that.
Alright.
I'm thinking more magic tricks. What else can I do?